This video is going to cover proving some trig identities using fundamental identities and working on creating our cheat sheet that has our rules and identities and some tools that we use. So here's the sheet that I suggest you keep. This is everything we've put on our cheat sheet here in the last two videos. These rules and tools were developed in the simplifying expressions video and proving trig identities video 1. So if you haven't watched those, you might want to do that. The identities and rules on the left aren't anything special. They're completely normal. The purple ones we use a lot. The blue ones are rare to use. On the right-hand side in our toolbox are things that we want to use to work on the left side of our identity, changing everything to sine and cosine, rewriting vertical division as horizontal division. Pythagorean is just something to always be thinking about when you see squareds. Factor, getting a common denominator, and splitting everything into two fractions. And then through this video, we're going to add one more thing. First, when I look here, the first thing I notice is that I have two terms on the left and one term on the right. So that is a sure sign that we've got to get a common denominator, right? That's the only way we're going to pull everything together. So here's the work for getting a common denominator. We would multiply everything on the left by 1 plus sine and everything on the right by cosine. So when I did that, here's what I would end up with by algebra. And then I have to square that binomial there. Remember that when you square a binomial, you get a trinomial. That a plus b quantity squared is a squared plus 2ab plus b squared. So when I do that, when I square that binomial, there's what I end up with. And again, the reason would be algebra. Now I notice I have a 2 secant up there, so I've got to get another 2 somewhere. I see that I have 1 2, but I think I'm going to have some factoring and stuff to do, because notice if I have a secant on the right, all I'm going to have in the denominator is a cosine, right? So that 1 plus sign is going to have to factor out. But if you look, I have sine squared plus cosine squared, which equals 1. That's one of our Pythagorean identities. So I can replace the sine squared plus cosine squared with a 1 using Pythagorean. And now when I combine that, I have 2 plus 2 sine, and there's my 2. So I can factor that out using algebra. We've used algebra a lot here. My 1 plus signs are going to cancel, leaving me with 2 over cosine. And then I have 2 secant using the reciprocal identity. So remember that we can only use one rule at a time, but we have several steps that use algebra here. So it totally depends on your instructions and your instructor and how things work. If you're one of my students and you're using ALEKS or you're using some other system where you only have to put in one reason and you don't have to put in every single step, since these two steps both use algebra, you could get away without putting in that first one and just use the second one. Likewise, these 3 steps use algebra, so you could get away with going straight from the Pythagorean step to the 2 over cosine. So just something to think about depending on what you need. Here, so this one is going to create a new tool for us because this is not necessarily intuitive. So we have 1 term on the left and 2 terms on the right. So we're definitely going to have something that we split, right? But we're going to have a fraction that we split somehow, but we can't split what we have now. But I want you to think back. So we have this. We have a plus b times a minus b gives me a squared minus b squared. And the a plus b and the a minus b are called conjugates. So what I can do here is I can multiply the numerator and denominator by the other by the conjugate, right? The other part of the difference of squares to force a Pythagorean identity, right? I had 1 plus sign, so I can multiply by 1 minus sign, and that will force the 1 minus sign squared. So we're going to put that in our toolbox in a second. So when we do that, our reason is algebra. And then now we have a Pythagorean identity here. Sine squared plus cosine squared is 1. So I can replace 1 minus sine squared with cosine squared using Pythagorean. Now my cosine and my cosine squared will cancel by algebra. And now I have my subtraction, right? Now I'm good. And 1 over cosine is secant by reciprocal. And sine over cosine is tangent by quotient. So then if we go to our toolbox, we can go ahead and add, multiply by the conjugate. And if you want to go ahead and specify that the reason we would do that is to force the Pythagorean, you can go ahead and do that. I can't think of a situation where that's not the case. Last one here. I have 2 terms on the left and 1 term on the right. So again, we must be in a situation where we are going to have to get a common denominator. So we will turn cosecant into 1 over sine using reciprocal. And then we're going to go ahead and get the common denominator. So I multiplied the term on the left by 1 plus cosine, the term on the right by sine. My reason is algebra. Now here, this isn't necessarily intuitive either since they're not next to each other, but I have a 1 minus sine squared, which is part of a Pythagorean. So I can replace the 1 minus sine squared with cosine squared. So I'm left with cosine plus cosine squared in the numerator by Pythagorean. Then I can factor out a cosine using algebra, and cosine over sine is cotangent using quotient. All right, good luck.